Hello, my name is Jonathan Weimer, and I will be presenting on STEM outreach through UAV technology. First, I'd like to give a huge thank you to the West Virginia University Honors Excel Program for making this project possible. West Virginia students are currently struggling. According to the National Assessment of Educational Progress, the number of students at or above proficient in mathematics is only reaching 24%. When I learned this, I was deeply troubled because a lot of upcoming jobs require a solid understanding of math and science. So I wanted to help combat this problem through creating a STEM outreach event using a technology that is both inspiring and useful. After researching several different technologies, I chose UAVs, commonly known as drones. I had four major goals for this project. The first one, I wanted to enhance the existing UAV presence at WVU. There are currently a couple clubs that use UAV technology, and I wanted to help them better their ability to use this technology and share that technology with students. Secondly, I wanted to help develop connections with people working with UAVs. The larger network I have with people knowledgeable in this subject, the more I can bring them together and help with this problem. Thirdly, I wanted to help develop a guide for students wanting to learn to fly UAVs because currently the FAA requires that you have a license to be able to fly a drone legally. And fourth, I wanted to help make an outreach curriculum by putting all the above goals together to help combat the lack of proficiency in STEM-related subjects. And STEM stands for science, technology, engineering, and mathematics. So the first organization I reached out to was the American Institute for Aeronautics and Astronautics, commonly known as AIAA. I reached out to their president and asked what I could do to help them with their UAV-related activities. And they told me three things. The first one is to assist with their outreach programs, and then to help make a presentation on for students explaining the basics of the aerodynamics behind gliders, and then finally help with their glider competition through making a glider launcher. So first I'll talk about the glider launcher. After I did a lot of research on already existing models, I came up with three different designs. The first design is what's called high start, and it uses a bungee cord that's anchored down by a tent peg on one end and the bungee is connected to the other end by the glider that's being launched. A picture of this is on the left. You can see the glider there is on a ramp, and on the ground it's kind of hard to see, but there's a bungee cord that's connected to it. And the glider is being held in place by a stopping mechanism. And once the mechanism is released, the glider will shoot forward, propelled by the bungee, and its own lift will cause it to rise up. And once the glider is directly above the anchor, the bungee cord connector will slip off, enabling the glider to freely glide around. The second design was a crossbow, and when we made it, it seemed perfect for launching heavier drones. However, because the bungee has a really rapid acceleration, we found it to be too forceful for most gliders. And in addition, we would also have to scale it up very large to be able to launch the maximum size glider that AIAA was wanting. And then finally, on the right side, we have a tripod-like design. And while it was perfect for getting gliders into the air quickly and reliably, it was not easily able to launch larger drones, and so we ultimately ended up proposing the high start design. The second organization at WVU that I reached out to was the Design Build Fly. And I asked them what would be most helpful, and they said that when they go to their competition in Kansas, they could really use some more certified drone pilots. And so what I did was I researched the FAA requirements for the Part 107 license. I spent a lot of time learning all about aerial charts, and different rules and regulations. And throughout all of that process, I wrote a guide helping on what I found to be most difficult and what I expected students to find more difficult. And after I did that, I took and passed the exam at an airbase. After I was all done, I recorded the entire experience from start to beginning, from start to finish, and that is all in a convenient document that is available for students. The next part I'd like to talk about is the high school outreach. So I didn't want to I didn't want to start all from scratch, and so I reached out to several outreach organizations in my area that commonly do STEM-related outreaches, and I talked to them, learned what was out there already, and I discovered a organization called the Robotics Education and Competition Foundation, who already have a wonderful guide for UAV technology outreaches. And so based off that, I wrote a curriculum for high school students, and to help put it together and to run it, I asked for some help from some UAV related clubs from WVU and got some help. Finally, I contacted some local high school students that I knew and showed them the curriculum to help gauge interest. So the curriculum, the major components of it there's three. The first one is the competition side of it, which would include the UAV race, which I'll talk about in just a little bit, and then the glider launch, which will be very similar to AIAA's glider launch competition. The second component is the engineering design challenges. In that we will be teaching students like the introductory curriculum for 3D printing, CAD, the design behind glider making, and understanding quadcopter components. And then the third category is programming. We wanted to teach very basic, rudimentary programming to students because we find that it's very, very useful skills to have in engineering. So we went with MATLAB, which is used extensively at WVU, as well as Python, which is a very easy to learn language and useful. So this is what the high school outreach drone race would look like. It is composed of hoops and loops, and as well as small, they call it artifacts, little objects on the ground that your drone would fly to and touch, and essentially act like you're picking up a payload. And all of it can be used, and we recreated it using cheap materials such as pool noodles and hula hoops and PVC pipe. Some of the challenges I faced while doing this project were adjusting timelines. For example, when COVID-19 hit, that was the year that I had planned to actually conduct the outreach, and because of that, I was not able to due to social distancing guidelines and keeping everyone safe. In addition, some of the WVU's UAV outreach events, such as the glider competition, had a much lower attendance because people were wanting to be safe, and so so the outreach did not have as strong as an impact as I had hoped. But looking forward, I do believe that the foundation for making these things are much stronger. So in summary, the curriculum has been created. It's currently being tested with high school students to see how it can be polished. AIAA was assisted with both their outreach activities, and also their glider launcher has been created. Thirdly, the presentation on glider aeronautics has been created. I did that for ALAA to help students understand the basics of glider aeronautics. And then finally, the FAA Part 107 guide for Design, Build, Fly was created successfully, which should be a huge help for students wanting to get that. Thank you for listening to my presentation. I'd be happy to answer any questions.